Okay, everybody, this is going to be the first in a series of videos on chemical reactions. We're going to be writing chemical or molecular equations. We are going to be converting them into complete ionic equations, and we are going to then be eliminating what we call spectator ions, showing the net ionic equations. Depending on where you are in school, you may or may not have to learn some or all of the solubility rules. So we might need to modify things just a little bit to meet the requirements of whatever course you're in. I do know some schools that give you all the solubility tables. For College Board Advanced Placement Chemistry, you have to know that all sodium and potassium salts are soluble. You also have to know that all nitrate salts are soluble. And hence you might be told something like this: solutions of sodium chloride and silver nitrate are mixed and a precipitate forms. Okay, so we would write a formula. Sodium chloride is NaCl. Silver nitrate would be AgNO3. The oxidation state of sodium is +1. The oxidation state of chlorine is -1. Silver is +1. Nitrate is -1. So these are correct formulas as written. Yes, silver can form a +2 ion. It's so unusual that normally we do not see the oxidation state of silver specified, so assume it's +1 if you're not told otherwise. That's the one element in the D block that's always +1. Okay? So what I do here is I like to take the outside 2, take this positive, bond it with that negative, and the inside 2. Take this positive, the Ag, and bond it with that negative, the Cl. Basically what I'm doing in a double replacement or metathesis reaction is I'm switching the positive ions. When I do this, I'm going to end up with NaNO3, and I'm going to end up with AgCl. Okay? So there's my chemical or molecular equation. I can predict the products. Now, you are told that the NaCl is aqueous. It is a solution. You are told the silver nitrate is aqueous. It is a solution. Okay? The question is, what about the products? Well, we should know that all sodium salts are soluble. We should know that all nitrate salts are soluble. Those are two real common ones that's worth knowing. If you have solubility tables you're allowed to use, you can just look those up. And you would find that the sodium nitrate aqueous is going to be an aqueous substance. Silver chloride is going to be the precipitate. That is going to be the solid. If you have solubility tables, you would find that all chlorides, bromides, and iodides are soluble, except silver, lead, and mercury 1. So here's my chemical or molecular equation as written right there. Now we want to break up anything that exists as ions. So you want to look at my sodium chloride. It's an ionic compound, metal to nonmetal, and it's aqueous. So in aqueous solution, the sodium ion would separate from the chloride ion. So I would write them separate like that. Now, check with your professor to find out if you have to put AQ in parentheses. Technically, the fact that we wrote them as separate ions means they're aqueous. The silver nitrate is also soluble. That will break up into a silver ion and a nitrate ion in solution. If a substance exists as separate ions extensively in solution, write it as separate ions on paper. The NaNO3 would also ionize. That does not form a precipitate. It will exist as sodium ions and nitrate ions separate from each other. The AgCl is a solid, so I write that together, AgCl. The fact that I wrote it together means it's a solid. Again, check with your professor if you do need to write the subscripts for the phases. Now I have my complete ionic equation. What I want to do here is I want to look and see what does not change. The sodium ion starts as an aqueous ion. It ends as an aqueous ion. Sodium did not change. The nitrate ion starts as an aqueous ion, ends as an aqueous ion. The nitrate ion did not change. These are called spectator ions. Spectator ions are unchanged in a chemical reaction. If I take my reaction now and I write it without the spectator ions, this is what I would get. Ag plus ion plus Cl minus ion turns into AgCl solid. These ions are both aqueous. Again, ask if you have to indicate the phases. This is our net ionic equation. That is what we see when we mix those two solutions together. Silver ion and chloride ion come together to form silver chloride. One more real quick one, and this one I've changed one little thing. We have to watch out for oxidation states, because if I have sodium chloride, NaCl, now I have lead 2 nitrate, which is going to be PbNO3 Okay? I'm going to take my positive ion from the left, bond it to the negative ion in the species on the right. That would give me NaNO3. And I'm going to take my positive ion on the lead nitrate and bond it to the negative ion with the sodium chloride. Okay, the positive from the left reactant bonded with the negative on the right reactant. The positive on the right reactant bonded with the negative on the left reactant. And this is what I end up with, NaNO3 plus PbCl. But here's the thing. After we do this, we have to check oxidation states. Do I have a proper formula? The oxidation states are not changing here. See, sodium is +1, chlorine is -1. Lead here is +2, nitrate is -1. Sodium is +1, nitrate's -1. But watch this, lead is +2, chlorine's -1. So the correct formula is PbCl2. That is lead 2 chloride. For the complete ionic equation, the sodium ion separates from the chloride ion. Lead nitrate is a solution. Lead ion separates from the nitrate ion. Sodium nitrate is soluble. All sodium salts are soluble. All nitrate salts are soluble. So the sodium ion separates from the nitrate ion in solution, and the lead chloride is going to be the solid precipitate. It does not break up into ions. It exists as a solid. Sodium ion is aqueous on both sides. Nitrate ion is aqueous on both sides. Eliminate them. The net ionic equation is a lead ion plus a chloride ion comes together to make PbCl2, and if we do have to balance this at this point in time, we can put 2 chloride ions. This is my net ionic equation. That's all for now. Until next time, happy studies.